Hi everyone, we're just going to wait a few more minutes to allow a lot of people to join, and then we'll start tonight's MOOC. So I'll give it a few more minutes and then we can start. Hi everyone. Hi, welcome to tonight's MOOC this evening. So CFG are delighted to partner with BT for tonight's dive into data with BT MOOC. So I will be delivering today's content or tonight's content. My name is Mary. I am a Code First Girls brand ambassador, instructor and mentor. So if you have any questions relating to CFG, any of our courses, our MOOCs that are upcoming or events in general, just please let me know in the chat and I'll try and respond to you as soon as I can or to the best of my abilities. I'm currently a data analyst for an automotive software company called Aptiv. I'm based in Ireland and I also completed my bachelor's, my undergraduate in maths and statistics in the University College Dublin. So that's a little bit about me. But just to let you know that this MOOC will be on or will be available for a week or two after tonight's session. So if you'd like to revisit tonight's content, feel free to do so by just clicking on the link you did today to get to here, basically. I'm going to share my screen and then we will dive right into data. So 1 second, everyone. Perfect. So I will be monitoring the chat. So if you do have any kind of comments or any messages, if you can't see the screen for the coding that we'll be doing later on, please let me know. And I will be able to kind of increase the font size as well. Okay. So what are we going to learn today? So we will learn what is SQL, what is databases, how and where can SQL be applied or are databases used. Then we'll go into a few examples using an online browser called CoderPad. So we'll play around with SQL and then we'll attempt a mini project as well in SQL. And then we'll talk about the roles and responsibilities, so or what careers you can get or that are available or that are out there that use SQL as a skill. And then we will finish off with today's content. Again, guys, if you have any questions, please put them in the comment section. And also, if you do want me to talk a bit louder, let me know as well. If my current level is fine for you, that's great. But if you do want me to talk a bit louder, just let me know. I do have kind of like a cold or a flu, so apologies in advance for any coughs, sneezes, anything that might happen. I apologize. I will try my best not to, but I apologize in advance. But without further ado, let's just dive right in. So, what is data? So, data is all around us. For me, data is information. So is how can we use data to the best of our ability? We gather information from our phones, from our emails, from when we go to the shops, scan our phones, to pay for a meal, to pay for our groceries, to pay for an event. All the data that we gather together, how can we use that or how can we store it? So the data is all captured in databases, and that's what we will learn today. It's all captured in databases and stored there, and then we're able to utilize the data that we have for various different reasons. So whether we want to create an app, to store an app that manages our our life, essentially, like our phone. It has different apps on it that we can use, or if you want to analyze data to make business impact. So if you're a data analyst, you can use the data within your company and create beneficial insights in order for your company to grow and to kind of meet their aims and their objectives. So that is data. So key point from this slide: data is information, any type of information, and we store data in databases. Okay. So what are DB and SQL? DB stands for database. It's like an acronym for databases, and a database can be considered as an ecosystem where data is stored in tables that makes sense, also known as logical clusters. For me, how I kind of describe databases for anyone is, so you can view databases as, let's say, a shopping center, where, sorry, a shopping center, like a massive shopping center. I'm not sure of one in the UK, but one in Ireland would be, let's say, Blanchardstown Shopping Centre. And in that shopping centre, you would have lots of different departments. So you can have Marks and Spencers, you can have House of Fraser, you can have let's say Eddie Rockets, McDonald's, different shops in your shopping center. And those different shops could be viewed as your tables. And that essentially is, you have a big database, and then within your database you have tables, and then those tables could make sense in a way that a customer can go to Marks and Spencers to do their grocery shopping, then they can go to House of Fraser to do their personal shopping, like getting clothes, and then they can go to, let's say, Eddie Rockets for their meal in the evening. So that makes sense. There's a relation between those two shops. Okay, so that's, if I was to kind of explain what a database is in layman's terms, that's how I would view it. I hope that makes sense for everyone. So essentially that's what a database is. It allows us to store data in relational tables in order for us to connect them together. So where does SQL come into where does SQL come into our use for databases? So SQL allows us to actually extract the information in our databases. So SQL is a language that allows us to take data from, let's say, Marks and Spencers, take data from Eddie Rockets, our tables in our database, and put them together. And then we're able to also perform some analysis on those data as well. Okay, so like the bullet point says, we use SQL to write code. Sorry, that should be write code, which we call queries, to access and retrieve the data. And then we can also slice our data into different dimensions depending on what we want to view. And you'll see that in the example that I will share, that we will run through later on. So let's go back and actually talk about the definition, what SQL stands for. So SQL stands for Structured Query Language. What does that mean? So when we come across the practice examples later on, you will see that we would have, let's say, a keyword or a magic word called select. Then we would have a specific way that we need to format the code in order for it to run. So you can have select our variables, and then you need to have another keyword called from, and then the name of our table. So that's what it means by structured query language. There's a certain structure that needs to be taking place when you're writing SQL in order for your code basically to run. So SQL is a special purpose programming language designed for managing data in a relational database. So for databases like MySQL, SQL would work great, but then there are other types of SQL as well. So there's SQLite, there's a Postgres SQL, and they work depending on the type of database that you have. So you have MongoDB, you have other databases, I can't remember them now, but there are other databases out there that use another form of SQL, but they all stem from the main language. They might just have tweaks here and there in terms of how you structure it. Okay. Relational database is a collection of data items with predefined relationships between them. And you'll see what it means by you'll see what it means by having a relation between one table and the other, because you would have links or keys that connect, that allow that make it possible for two tables to be connected, because they would have fields or fields, which is also can be described as a value, like a column value, that is coming to both tables. If that doesn't make sense, hopefully the example that we'll come across in a few minutes' time makes complete sense. Okay. So like I said, there are lots of SQL languages, different types of SQL out there, but we will only focus on MySQL. So here are just the snapshots of the apps that use SQL. So you can see, that use that have databases behind them, and you're also able to query those databases with SQL. So you have Pinterest, PayPal, YouTube, Netflix, even big companies use like Facebook, or Tesla or Booking.com. They all use MySQL as a database behind them, and then you can query using SQL the data in those databases. Okay, now where to use SQL skills. So there are many roles that require or simply would benefit from SQL skills. However, there are, one second, Um, sorry guys, sorry, some interruptions in the background, apologies. There are many roles that require or simply would benefit from SQL skills. However, there are generally three main pathways that use SQL and databases on a daily basis. And so we're just going to review three of them, which is software development, being a data architect, and then data analysis. So these are the three common career paths that would use SQL on a daily basis. So data science and analytics. So how does it work? How do we use SQL to in our day-to-day basis? On a day-to-day basis. So first of all, we get a problem from the business. They're asking us to collect information or to analyze a certain type of information. So they would come to us with a problem. We need to frame the problem in a way that we know where we need to collect data, how to prepare the data, and then how to present the data. So that's the first process, to frame the problem. Then we need to collect the raw data. And this raw data can come from various different sources. So, and these sources, like you saw in the previous two slides back, can come from Facebook, can come from Tesla, can come from Booking.com, depending on what the problem is. And these sources could have MySQL databases behind them. So you would have to use SQL to extract the relevant data. Then you need to prepare the data. Again, you can do so using SQL, and you see how we will do so in during our practice examples. And then preparing the data and then allows us to also normalize the data in a way that allows us to explore what is actually in there. So let's say we're looking at employees' data. Are there certain employees that earn less than 50,000? Using SQL, we can actually analyze the data to explore different characteristics in the data and gather key points and key values. And then from our initial exploration, we can perform an in-depth analysis. So it could be that we want to perform, let's say, machine learning algorithms. That is possible within SQL. Or let's say we wanted to apply a function, create a brand new function that does a number of steps. We could create that big function in SQL, and all we have to do is run it for all the business users have to do is just run that function, and then whatever output they want is generated to them instantly. So that could be it as part of the analysis. Sorry guys, runny nose. And then the last step could be to visualize the data. So whether the business wants to see the data in histogram form, in the pie chart, let's say in a dashboard, we can do so using SQL as well. Okay, so that is how to use SQL if your career or if your background is in data science or in analytics. What about if it's in software or app development? So we could thank you. So if you were working as a front-end developer, a back-end developer, or a full stack developer, which is basically a combination of all two, then you would use SQL on a daily basis because you would have to connect to the database. So your database would allow you to store multiple information. So let's say you're working as a trader on a trading desk, and you had multiple data that you were mining constantly. You need somewhere to store this data, and for you to store this data, you'd have to store it in a database. So, or let's say you're building an app, let's say a fitness app, and you have multiple data that coming from your users. You want to track how long they spend on the app. You want to track their performance. Yes, let's say you're also tracking your calories. Where are you going to store that information? You'd store it in a database. So that's again is how in software and app development, databases come in handy. And then the reason why we have SQL is because we have SQL to extract the relevant information from that database. Okay, so that's software and app development. Now, what about as a data architect? How do you use databases, and how do you use SQL as a data architect? So what you would do is you a data architect will have multiple databases, and their job is to see how can they connect these databases in a way that makes sense, and in a way that allows for is it non-duplicated? Sorry, my words are just mixed up today. I think unique, let's say unique records is presented to the business users. Also, there's a logical flow of data from one database to another database to the user. So there is a sensible flow of data between databases all the way to the business users. So I guess this diagram shows pretty well what a data architecture will do. Their job will be try and find a flow. Let's say take this red arrow here to try and find a flow from this database all the way into this computer, and they would have to do it for whatever the business user will be querying the databases for. Sorry guys, one more second. Okay, sorry. So that's data architecture. But there are also various other roles that use SQL. So we've touched on data analysis, data analysts, data scientists. We have data engineers, and then you have DBA stands for database administrators. But we also have people like product managers, marketing specialists, business analysts that use SQL as well. So there are various roles in the tech community that use SQL. And so but you don't have to be very, you don't have to have an in-depth knowledge of how to use SQL. Like the basics would do for like a role in product manager, or a marketing special. They would know the basics of SQL. Okay, perfect. So we've covered what is SQL and databases, how and where we can use SQL, and how our database is used. We've covered that. So now let's dive right into kind of practice questions, okay? And how exactly can we use SQL? So what we're going to do is we're going to go to this website. So I'm going to put the link in the chat. So copy. Okay, perfect. So I've put the link in the chat. So what you can do is you can copy that link, paste it into your browser, and it should open up a site like this. Okay, now what this is it's an online interface that allows you to have a feel for what it's like to actually code in within an interactive oh, I can't think today, interactive environment. So like a coding environment like IntelliJ, PyCharm, Jupyter Notebook, Visual Studios. Instead of you being able to instead of you having to download those IDEs, you can perform your operations on an online interface like this. Also, an additional bonus would be for companies who want to kind of test their interviewees, test their skills. So they would have their interviewees perform some kind of test here, and they would be able to kind of see their skills and abilities coding as well. I have a question from Bianca. What does DBA stand for in the job roles? It stands for database administrators. So let me just quickly type it in. Come on. Database administrators. There you go. Perfect. Thank you so much for your question, Bianca. So now we have CodaPad. So what we need to do is we need to change from having a Java interface to having a SQL interface. So you go click on this Java button here and then look for MySQL. And when you do so, it should automatically reflect my screen basically. So your screen should be the same as what I have on my screen now. Now, what I would ask you to do is everything from row 26 down, highlight and just delete. Okay. Now, you don't have to follow me or copy me while I code, but if you want to, for just some of the basic stuff that I'll be doing, feel free to do so. But it is good to know that this link will be available for a week or two for you to revisit. Okay. So what is here is known as like a schema or an entity relational diagram. And sorry. What is known here, so from this diagram here is known as an entity relational diagram, and it actually shows you the relationship between each of our databases. So employees here is one of our database, projects would be another database, employees underscore projects would be another database, and departments would be another database. And within our databases, we have our schemas. So the schema would be a schema would be defined as what would it be defined as? Like a description of what is in our database. So we would have the names of our fields, also known as our columns, in our data frame. So ID, we have a column called ID, we have a column called first underscore name, and then we also have the data type associated to that column. So we know that our our IDs are all going to have data type integers. Our first names are going to be have data type varchar, which also means variable characteristics. So what that means is that for a first name, we don't have a defined amount that our first name can take. So it could have defined amount of characters. So it could have, let's say, 50 characters for a first name. So there can be a very, very, very long first name in our column. And this varchar keeps note of that. Keeps note of that. Same for our last name. And then we have salary, so that's letting us know that that's an integer, and department underscore ID, that's another integer. But this here, sorry, I know it highlighted project, but if you focus on employees here, this is the schema for our employees database. Similarly, for projects, we have something similar, but with different field names and departments as well. But notice these links here that connect one database to the other. This allows for us to call it relational database, because we're able to connect one database to another database. And you would see in a few examples, and also in our mini project, how exactly we're able to connect them and why exactly they're called relational databases. Okay, so is everyone with me so far? Oh, there's a lot of questions. One step back, please. How do you get to the screen? Oh, sorry. Perfect. Do you think specific math concepts are needed in understanding SQL? I'm coming from a maths background. I learned SQL kind of a year ago, and you don't need to know maths to know SQL for definite. I can confirm. Let me see. Any other questions? Okay, perfect. No other questions. Thank you, everyone. Thanks for the help. I like seeing the community. I love it so much, especially when I'm not able to see the chat. When I'm on CoderPad, I do love the community. So please try and help each other if I'm not able to see the chat in time. Okay, perfect. So what I'm also going to do is I'm going to delete this line of code as well, because this is not what we're going to be doing yet. It's very advanced at the moment. So we're going to bring it back a little. We're going to focus on the basics and then work our way up. Okay, so I'm just going to delete this. And then let's work on some practice questions. So before we go ahead, I just want to explain what is on the left and what's on the right. So on the left-hand side is where we're going to run our code. Sorry, my nose running again. So on the left-hand side is what we're going to run. It's where we're going to type our code. And then on the right-hand side is where we're going to run our code. So our results from our databases will show up here. So again, in other words, we are going to query our databases here on the left-hand side, and the results from our query is going to show up on the right-hand side. If you ever want to reset what's on the right-hand side, you can just click reset here. If you want to preview what our database looks like, you can preview it here. So we have our schemas. So what I did was I just clicked on database. That's next to program output. And you can see our schema is in more in-depth. Our schema gives us, this link here, or this tab here, gives us much more information on the schema of our databases as compared to this relational diagram here. Okay, now let's dive right in. We're here to code. We're here to dive into data. So let's go. Let's dive right in. So what we're going to do first is we're going to perform a simple query. We are going to extract the ID, first name, last name, salary, and department underscore ID from our employees database. So the first thing we're going to do is we're going to use a magic keyword, which is select. So what we're doing now is we're going to perform a select statement. So we want to select the ID, first name. So after each variable, just have a comma. So first underscore name, last underscore name, salary, and department underscore ID. Okay, so this is the reason why SQL is called a structured query language, because we have to start with a select statement if you're performing a select statement. And then we also need to have the variables or the names of the names of the fields that we're interested in. We have to have them right after our select statement. Now, what we're going to do is we now need to indicate exactly where we want to extract these variables from. And in order for us to do so, we need to actually add another magic keyword, and that magic keyword is from. We're going to select all these variables from employees, because employees is the name of our database. Perfect. So if I click on run, on the right hand side, it should give me my database. So this is what my database looks like. This is one of my this is a table, and you can see ID, first name, last name, salary, and departments. So these are called fields, and then these are all the entries in that all the entries for that specific field. Okay, cool. Is everyone with me so far? Perfect. There aren't any questions, so I will assume you guys are with me. So we've just literally ran our first code in SQL. So we've extracted from employees all the fields in that table. Now let's say we want to do this quicker. We want to have a shortcut and select all that information without having to type all these names out. So we can easily do so using a star. Okay, and if I select run, it should give me the same information back. So that's a shortcut. If you're ever in a hurry and you don't want to write down all the names in the database, sorry, in the table, you can just say select star and then just select star from your table, which is employees. Okay. Now, let's say I want to slice the table in a way that it only gives me the first name and the salary. So what I need to do is I can say select first underscore name and salary, and then this should give me a subset of my main table and should give me just the first name and salary. Now this is interchangeable, like it did. There isn't a specific order when you're writing down the fields. You can simply say salary and first name as well, and this should give you back the same information, but in different forms. So salary will come first and first name will come second. Okay. Now, let's say I want to, what do I want to do? Let's say I want to extract all the data for my employees. Let's see, all the data for my employees that have surname or last name starting with Peterson, or sorry, surname Peterson. So it should give me information on Mike and Ian. So let me see how can I do that? How can I query my database to give me all the information for any employee in my database that has a last name Peterson? So I'm going to go back. I'm going to reform or revert. Sorry, that's the word I'm looking for. I'm going to revert back to select star.employees. Now, what I'm going to do is I want to extract all the information where last name is Peterson. Now, notice what I said. Notice the keyword that I just said, where last name is Peterson. So that's essentially what I'm going to do. I'm going to use the keyword where and then last underscore name equals Peterson. And then Peterson is going to be in quotation marks because it is a character. So it is a string. So Peterson. Now if I run this, it should give me, sorry, let me scroll down. So it should give me Mike Peterson and Ian Peterson. So these two entries are are giving me a result because they both have last name Peterson. Okay, is everyone with me so far? Sarah, you have a question. Could you do select star from employees on the same row? Yes, you can go ahead. You can do that. I put it on sometimes. Sometimes I go back and forth. I put them on different rows just in case I would have a script that has really long lines of code. Like I might have a script that has 100 lines of code, and I want to be able to read it in a way that it's well formulated formatted. So I would have it in different lines. But if I'm only writing a script that's like 20 lines, then I'll keep it all on the same row. Also depends on how kind of lazy I am as well. So but yeah, you can have it all in one line, no problem. Right. So now we've queried for employees that have last name Peterson. What about if our employees have last name Peterson and let's say salary less than 5,000? So let me say that again. So I want to select all the employees in my database that have name Peterson, where their last name is Peterson and their salary is less than 5,000. So I already have the first part of my query done. Now, if I want to add that salary is less than 5,000, I just need to add another keyword, which is and then I have my variable salary, and I say equals, it's less than 5,000. Sorry, 50,000. What am I saying? 50,000. So if I run this, it should only give me, so notice we have Mike and Ian, but when I run this, it should only give me Mike. And there you go. So that's my query working. So I have a functioning query, and I think you guys would know or would notice maybe by now that when I'm saying the query out loud, when I type the query in SQL, it follows the same structure as the English language, as what I'm saying. So that's another reason why SQL is it's very nice to learn, because it follows the same structure as as if you were saying like the English language. Okay. So SQL and Python, they follow the same flow. So as you're speaking English, no matter how basic or advanced you are in English, it follows the same SQL. Oh, sorry, the same language. The same language format. Sorry, my brain is doing the most today. Okay, perfect. So what about we wanted to look at salaries, wanted to see for all employees, which employees have salaries between let's say 3,000, oh, sorry, 30,000 and 50,000. So all we'll have to do would be to say, keep this first part of our select statement because we want all the information. Sorry guys. We want to select all the information from employees, and then we want to filter. So when we're using the where clause, we're actually filtering our database down further. So we're going to filter on, let's say, the salary field, and we want salary to be between. So therefore our keyword is going to be between I say between 30,000 and 5,000. So this is no longer needed. So we're going to select every information from our database. Then we're going to filter it down further by looking at by looking at employees that have salaries between 30,000 and 50,000. So when I run this, it should give me the employees that earn earn between 30,000 and 50,000. And those employees are Colleen and John. Right. Is everyone with me so far? Perfect. Yeah, I just saw the comment. Very easy to grasp. Yes, I would agree. But I would agree in the fact that it follows like the basic format or basic structure of the English language. So yeah, definitely right. Perfect. So now we've done practice around with simple queries. Now let's say we wanted to look for employees that have a last name with an I in it. So let me clear this. I'm gonna clear my let's say my console so that there's nothing showing here or it's fresh and brand new again. So I just click the reset button. Now let's say I want so I'm gonna run this again so I see my database. So let's say I want the employees that have an I in their last names, like Smith, Muffinson, Ninson, and Mills. So let's say I want those employees. So what I would do is first of all, I have to select my database, which I'm having the select statement. Now I want to filter my database further. So I would use the where clause. And then I would say, because I'm focusing on last names that have I in them, so my field of interest is going to be last underscore name. And then I'm going to use a keyword. It's a new keyword. So, but it's the keyword is called like. Oh, sorry, I don't know why I said list. Like. And what that does is it goes into last name and goes into the last name and looks at all the entries that are like what I'm going to put next. So like percentage sign and I and percentage sign and then close. Okay. And what this does is it looks in my last name and it looks to see whether I is anywhere in the middle. Is anywhere in the middle of my last name. So if it's not at the start, if it's not at the end, if it's in the middle, it's going to give me all records that have I in the middle of my name. So if I run this, it should give me back John, Ava, Colleen, and John again, but this time John Mills. So that's another way to kind of search patterns in our data set. If I wanted to change this, so this is just an introduction into pattern search with SQL. But if you want to know more about how to use like percentage signs with SQL and using the like operator, I would definitely say join one of CFG's data courses, or you can do another course, a data course, let's say on Coursera or Udemy, and they'll be able to teach you, or you can watch a YouTube video. But let's say I wanted to look at last names that start with, let's say P. I think that's the right notation. So if I run this, nope, that's not. So sorry, one second. I always get confused with this. So you have to have P first. So what this would do is it would look at all the last names that have P in the first position, and then it doesn't matter what comes after. But you just need to make sure that P is in the very first position. And as I just ran this, you can see that that query worked because Mike and Ian are back again with us because their last name starts with P. Okay. So perfect. So that is us kind of playing around with SQL. So if there aren't any questions, I think now would be a perfect time to jump right into our mini project. So I'll give it a few seconds for people to maybe type some questions if they have it. If not, we will jump right in. Yeah, I love that as well. That every time it says bye, but that's not SQL specific. That's just for CodaPad. They do that on CodaPad, which is very sweet. I do love that. Is it case sensitive? No, it's not case sensitive, but it would be case sensitive with respects to what you call your field. So what I mean by that is, for example, we have ID and that's in smaller letters. But if I had ID, if I was to run select ID in capital letters, this shouldn't run for me because that's not what ID is called. ID is in small letters. So if I run this, it shouldn't. Oh, it did work. Interesting. Maybe it's because it's CodaPad. But if you were using the MySQL workbench or SQLite, or depending what database you're also using, then it could be case sensitive. But I would just say if you're working with like databases and they have a specific name in a specific form, definitely keep it the same form. Don't change anything. That would be my advice. Also, if you do want to differentiate between the keywords in SQL, like select from where, if you want to have that in capital letters instead of smaller letters to distinguish between the difference, I'll definitely suggest doing that as well. Keeping them in uppercase rather than lowercase is what I mean. Okay, another question. How do you make it a keyword? Does it become red and violet automatically? Yeah, it will change a different color automatically. Just like in Python, if a code has a specific function behind it, like print would turn a different color in let's say Jupyter Notebook. So yeah, it's all IDE specific, but it will change a different color. Will all SQL databases use select from where and between? I've not seen any databases not use that, so it should. Yeah, all SQL databases should use all those three keywords and a bunch of others as well. Would you be able to elaborate on the group by function? Yeah, definitely. So I can do a quick example on the group by function. So if I wanted to select all employees in my database, so I select all employees, doing it the lazy way, and I want to group them by, let's say, what do I want to group them by? Okay, no, actually, sorry, guys. If I want to select the employees in my database that have last name Peterson, so last underscore name, Underscore name. Would that do it? I think I'm picking the wrong database to do that. Okay, right. Let's look at another database. I think that might be better. Let's look at, let's say department. Let's look at the department database. And we are going to look at department ID. Print underscore ID. And we are also going to show you how to do a left join. So I'm going to count. So I'm going to incorporate a lot of things in here. So I will explain it as I go along. But I want to select department ID from my database. I want to get a count, let's say a count of the last names in my database. And let's say I want to, okay, we'll keep it basic for now. And I'm going to say from, get that information from employees. So sorry, I already have that below. And now I want to group by employer, group by department ID, let's say. So essentially, what am I doing here? What I'm doing is I'm selecting the department ID in my database. I'm also getting last names, but this time I'm counting them. So I'm going to count how many last names or how many employees essentially, because I could also interchange this with first name or I can interchange this with salary. But basically, I want to know how many employees in my database employees has department ID, let's say 1, 2, 3, 4, etc. So if you notice here, this is our database. 3 of our employees have employment ID 2. 1 and then only 1 have employment ID 1, 5, and 3. So if I run this, it should give me 3 employees have employment IDs 2. So running this, you can see that these are our employment IDs, and you can see that 3 employees have this department IDs, okay, whereas the others only have 1. The others only have the other department IDs only have 1 employees associated to it. So what did I do in this query? I basically selected the department IDs, and then I got a count of my last names. But I can switch that, and I can say sum of salary, which would then give me the total salaries for all employees per department ID. So if I run this, I would get the sum salaries for an employee that has ID 1, an employee that has ID 2, an employee that has ID 3 and 5. Okay, so let's run that. And you can see that is another way for us to kind of run the data. So what have I done here? I've done a mixture of using the group by. I've also added functions within our select statement. I know we kind of sped through it, but I hope that was clear. And then I'm going to do a quick thing. I'm going to show you guys kind of how to rename our column names if you perform an operation like this. So at the moment in our return statement or result set, it calls this field sum salary. Now, if I wanted to present this to a business user, they would understand what this is. But what if I wanted to rename that field so that it has more information? So what I would do is I would use the as keyword, and this would rename this whole sum salary name or operation and give it a name. So I'm going to give it a name called number of employees, all within quotation marks. And then when I run this again, you should see my field name changes. So now there's a description behind the name. There's a description behind the field name. Okay, is everyone with me so far? Would you be able to elaborate on? Oh, yes. Yeah. That's what I just done. So what the group by function is, it allows us to group our data by a specific, let's say specific ID, or let's say specific field that we wanted to. Sorry. So I can group by department underscore ID, but let's say I wanted to group by last name again. So let's say I wanted to group by last name. Remember, we have Peterson in our data, and that occurs twice. So what would happen is that it would group by ID and also group by last name. But notice that Peterson isn't showing up here. That's because I've not added Peterson as a field. Sorry, I've not added last name underscore as a field here. So now when I run this again, it would show last name and then Peterson here. And then it would sum the salary according to Peterson. Okay, everyone's with me. So first of all, it groups by last name, and then it will group by department underscore ID. Okay, perfect. So I think now is the time to jump right into our mini project because we're kind of running behind. So if there are any questions, I will try and answer them at the end, but let's try and kind of play around with SQL while doing this mini project. Okay. Megan or Megna, I hope I'm pronouncing your name right. Group by function is always paired with a aggregate function. That is usually the case. Yeah, that's usually the case. Not always, but offhand, I will say my answer is yes temporarily. But please, I would say do your research. And Google is your best friend. Like as a coder, I use Google 90% of the time. It's my assistant basically, and you find that most coders would use Google 90% of the time. So I'll definitely say research that. Go on Google, go on YouTube, and you'll be able to find your answer. But for me, I would temporarily say yes, but I'm only 60% sure. I can't give you a definite answer because my head is doing all types of things today. Okay, and Natalia, is there a comprehensive list of commands with examples? If it means SQL commands, you can definitely look it up on W3 Schools, and then go to the SQL tab, and then they'll be able to take you through every single code or command that is being used in SQL. Okay, so we have our mini project, and our aim is to prepare a report that includes employee name, department, current salary, projected salary, and bonus. So for the projected salary, for the projected salary and bonus, we don't have that yet. That's going to be calculated in points 1 and 2. But let's work on actually preparing this report first of all. So we can do so by just using the select statement and extracting the employee name, department, and also their current salaries from in SQL. So let's do that. So we've come across this already. So we're going to use our select statement. We're going to use department ID. We're also going to use their first name. So we need that first underscore name. We need their department ID. We also need their salary. Okay, so if I run this, all that information, sorry, I'm just going to reset again so I can start from a new fresh screen. And then I'm going to run this again. Okay, perfect. So this is us performing our select statement. Oh, sorry, I just realized I didn't share my screen. Sorry guys. So I just performed the select statement and I used department ID, first underscore name, last underscore name, salary, and I'm extracting that information from our employees table. Okay, so that is initially the first thing. So let's look back at the question or the requirements. So prepare a report that includes employee names, department, where they work, current salary, projected salary, and bonus. So let's maybe skip over 1 and 2 for now. Let's focus on 3. So let's say, Actually, sorry, we haven't actually finished this question or this first part because we need to actually get the department information, and we don't have that. All we have is the department ID. So in order to get the department information, we actually need to look at our departments database. So I'm going to, let's see, what am I going to do? I'm going to say select underneath. I'm going to say select star from departments because I want to see what it looks like in my department database. So let's run that. That's not going to work because I need to end my select statement with a semicolon. So that's if I run that. So there are certain syntaxes, because I've only been writing one line of code in MySQL, it's been able to run that. But because I've added another line of code, I need to follow the syntaxes of MySQL. So I need to close my select statements or whatever statement that I write with a semicolon. And that's best practices unless you get an error returned like I did earlier. So that's the error statement that I got back. So I selected star from the departments, and these are my department names. So this is what I actually need in my select statement. So how can I combine these two queries together? So I can do so using the department IDs. See them? So all I need to do is connect these two tables. And you might ask, how can I do that? But I can do so using a join. And what I need to do is I will select all these from employees. Actually, I don't need the department ID, but I do need the department name, and it's called name. So I'm going to replace department ID with name. But I'm going to select it from employees, but I need to ensure that I'm actually joining the data sets together. So I'm going to say, what am I going to say? I'm going to say left join. I'm going to left join departments. Okay, so now I'm going to left join departments, and then I need to indicate what I'm actually joining on. So what exactly am I joining departments and employees on? So I'm going to left join department, it's called department underscore ID in employees. So those are the two fields that are the same. So this allows us to actually relate the two tables together, hence the name relational database. So employees equals ID. Now, sorry, not employees. What's departments underscore ID. Now our query isn't finished yet. We've not actually linked it on together. Linked the two tables together because we need to add aliases to our. We need to add aliases to our tables. So what I mean by aliases is that we need to kind of rename employees and departments in a way that we can actually assign them to our variables. So I'm going to select all these variables from employees E. So instead of calling my table employees from now on, it's going to be called E. And I'm going to left join departments, and I'm going to call departments D. And now I just have to rename this and say, left join departments on. So another keyword on, and then D dot departments. So that's ensuring that, that's letting the CoderPad know, or the system know, or the computer know that departments underscore ID department underscore ID is coming from employees. So sorry, I should actually rename this as E. It's coming from the employees table, and also the ID is coming from the departments table. Okay, now I need to rename all these fields as well because name is coming from departments. First name is coming from employees. Last name is coming from employees. And salary is coming from employees. Is everyone with me so far? Oh, sorry, guys. Oh my goodness. Sorry. Wow. So I spent, oh, apologies, guys. So let me quickly run through this. So I am selecting, wait, let me just double check that worked. Okay, yeah. I am selecting, so I'm selecting name from our departments here. And then I'm selecting first name, last name, and salary from our salaries table here. And now I'm left joining them on departments, and I've given them an alias. I've given departments an alias D, and I've given employees an alias E. And I'm making sure that I'm joining on the fields that are common in both tables. So department underscore ID and ID in departments. Okay, now I'm going to run this. There you go. I run this, and now I'm getting the name, first name, last name, and salary of our of the two tables. So I've basically linked the two tables together. And if you notice, the ID the ID and the department ID link up because anyone that has ID 1 would have reporting as a department name. So you can see John Smith has reporting as a department name. Notice notice Colleen, Mike, and Ian have all have departments engineering. That is because they all have IDs 2. So you can see 222. So now that shows, or that, yeah, that basically explains why we need relational databases, and because it allows us to relate one table to the other using common fields in both. Okay, so now if we go back to the slide, we've done number one. Well, we've done the prepare report part, and then we've also done but we also want to kind of also tick another box by doing another easy part. So we can do point number 3. So that's another easy part that we can actually complete. So we don't want to include silly department name in our select statement. So what we can do, so let me make sure I'm sharing the code pad again. So we just need to have a where clause. We just need to tell our SQL statement to select everything we need, but where b.name is silly. So I'm just going to say d.name, and then I'm going to say silly. Sorry. We need to have our quotation marks. So silly, what's it called? Silly walks. So now we need to make sure our select statement knows not to include this. And the symbol or the operator to say do not include this name is going to be this, which is like alligator close, alligator open, or I'm not really sure how to describe it, but it basically says, it basically means an operator to mean do not include or not equals to, sorry, that's what it means. It's not equals to this. So we're going to say select everything in our database, but don't select the entry or the record that has department name equal to city walks. So if I run this, you can see the difference between the two tables. Ava Muffinson is not included. Okay? Perfect. Can you please repeat the join statement, where and why and where it is used? So the join statement is used to join the two tables together. So it's used after you define your first from employees. So when you're initiating your first select statement, and you say from your first table, you then say you want to join. So you then initiate your join. So you then say that I want to join my next table. So it would go from employees, left join or inner join or whatever join you want to perform, and then your other table name, which for in our scenario or in our case is called departments. So I'm going to select all this information here from employees, and then I'm indicating that I want to join on another table. So then I would say left join department, which is the name of our other table. And then we need to make sure we can specify what exactly we're going to join on. So we're going to join on department underscore ID and ID. So department underscore ID comes from our employees table, and ID comes from our departments table. So that's what we're specifying here. So whenever you're doing a join in general, you need to have the left join keyword, the on keyword, and then you need to specify what fields you want to join on. Okay, and why we have the alias. So an alias is kind of like a shortened word or shortened way we call our tables, or call the name of our fields, or a way we want to rename our fields. We use aliases employees E and departments D to shorten employees. So that way it's easy for me to distinguish what variable comes from which table. And that's why I have E dot first name, E dot last underscore name, E dot salary, and D dot name. Okay. Perfect. Okay. So we've just done number 3. So we don't need to worry about number 3 now. So let's go back to number 1. So we want to assume 5% increase for everyone who currently earns less than 50K per annum, otherwise 3% increase. So let's look at how we can do that. Let's look at how we can do that in our database. In our query. What's going on with me? So in our query. So what we're going to do is we are going to add in here kind of the case when something happens. So the question asked us, let's revert back to the question. We want to assume there's going to be a 5% increase for everyone who currently earns less than 50K. So let's work on that. So for everyone who earns less than 50K, there's going to be a 5% increase. So we're going to use the case keyword. And why we're going to use that is because it's going to allow us to account for every scenario in that point. So for the case or for the event that everyone in our employees table earns less than 50K, so we're going to say case when. So case when. So we need another keyword, which is when. I don't know why I increased this. So case, and then let's say when. Case when, let's say salary is less than 50K. Case when salary is less than 50K, then we want salary to increase by 5%. So then salary, E dot salary, is now going to be E dot salary plus E dot salary, salary multiplied by 0.5. Because this is going to calculate my, 0.05. What am I doing? This is going to give me my 5% extra, and this is going to add that extra to my salary. So that's one of the cases that we. Now, what about the other case? So the other case is when, for everyone that earns more than 50K, so for everyone else, they would then get an increase of 3%. So let's look at how we can do that. So we've identified the first case, which is when employees earn less than 50K, then they would get an extra 5% in their salary. But if they don't earn greater than 50K, they would get, if they don't earn less than 50K, so if they earn greater than 50K, then they would get a 3% increase. So all we have to do is say, if this condition is not met, then, or else, else E dot salary, plus E dot salaries, E dot salary 0.03. So I don't need to say, if I wanted, I can say E dot salary greater than or equals to 50,000, but I don't need to do that because the only other condition in that point, in that first point, is that otherwise or else salary increases by 3%. So all I have to say is else salary plus the 3% of that salary. So if I run this, oh, okay. Sorry, I actually need to give it a name. I need to give this field a name. So I'm gonna rename it and call it end. I'm gonna say end as. So this is going to end. The end is gonna give end my case statement or case, yeah. Sorry, I can't think of the word. Case statement or case operation now. And then as is going to allow me to rename this field. Because if I have to run this now, would just give me a field and it would just be something like this without any name. So we don't want that because it looks very, very messy because it just has our case statement there. That's going to be long. We don't want that for our relational database or for our output. So we are going to call it as new salary, right? And I'm going to run this and it should look a lot neater. Oh, sorry. I have to use my quotation marks and then run this. And there you go. That's my new field, new salary. And this is showing all my increases of 5% because the salary is all less than 50,000, sorry. Whereas this person Ian is earning more than 50,000, therefore he'll only get an increase of 3%. Okay? Right, so is everyone with me so far? Perfect. Right, so we're almost done. Now we just need to focus on the second point and then we will be finished. Could you use E dot salary multiplied by 1.05 to add on the 5%? Yeah, you can. Yes, you can definitely do that. Give it a try and let me know if it works in the comment section, Emma, because you can definitely do that. So notice the case statement gives you allows you to kind of think of think of that as an if statement. The case statement is sort of like an if statement. So if employees earn less than 50K, do this, else do this. It's kind of like an if statement, but it allows you to consider multiple scenarios. So that's why you use a case statement in SQL instead of an if statement. But notice the second point. It says bonuses for all employees are going to be 5K, except for the engineering department where bonus amount is 7K. So what this is saying is if department name equals engineering, then the bonus amount is 7K, else it's going to be 5K. That's what I'm gathering from this statement. If anyone else is gathering something else, please let me know. But because I read it like that, I'm going to use an if statement. And oh, great, Emma, it did work. Perfect. Cool. So let's try and just finish off the second point. So now I'm also going to add a line here, and I'm going to implement the if statement. So what that's telling me is I'm going to use the if statement, and it's saying if d.name equals engineering. Let me close out that. Then they would get a bonus of 7,000. Else they will get 5,000. Perfect. Now I'm going to rename that to be called bonus. Bonus. And if I run this, it should give me a new field and it should call that field bonus. So let's run that. And it didn't. So let's see, why didn't that work? Maybe because I did not say, what's my department called? Engineering, 7,000, 5,000. What did I do wrong? Can anyone tell me? D.name. Let's see. Oh, here it is. You should always read your errors. I wasn't looking at my errors. You have an error. Check the manual that corresponds to use if. So my if statement didn't tell me anything really. Oh, sorry, my error didn't tell me anything. But let me see if I wrote with a capital If. Would that work? No. So let's see. D.name. Oh, maybe it's 2 equals? No. What's going on? Can anyone notice what I did wrong? There's no else statement. The else statement should be covered in here. The else statement. So the if statement is saying if D name is equal to engineering, then do this. Else, if it's not engineering, do this. That's what it's saying. But let me see. Oh, I know why. Because I don't have, notice I have a comma after this one, and then I don't have a comma after new salary, because this is a new field. New salary is a new field, so I don't have a comma after it. But now, this doesn't matter. Now, if I run this, it should give me, yay, it should give me my table. So you can see here, bonuses of 5K is given to employees that have departments that aren't engineering. So reporting and marketing have 5K, whereas everyone else has 7K. And that's it. That is us done with our mini project. Oh, and you got that. I should be checking my comment section much frequently. But yeah, well on the ball end. And I guess a lot of people also noticed that as well. Perfect. So that's basically it. That's us finished with our mini project. So let's kind of close up and see what are the next steps. So we've just finished our mini project. So what about the roles and opportunities of getting into tech? So you can get into tech as an entry level role. So look for entry level roles, and they're great ways of starting your career in tech, and also learning how to code SQL and not be kind of under pressure to kind of be advanced in your knowledge and in your skill. It'll also give you an opportunity to work at building your knowledge, building your experience, being able to adapt to different scenarios that you might come across. So entry level roles are good for that. Or you can have a career change. So you can move from having let's say a sales role straight into a tech role, and you can do so with courses such as Code First Girls career searcher courses, which actually allow you and give you the foundation as well as the basics. The basics of foundations are kind of the same thing, but it gives you the knowledge that is as at a high level for you to jump into a role in tech without having to worry that your knowledge or your experience isn't as in depth as your colleagues or as your peers in that same profession. So that's what a career change could look like. But also there are various courses out there similar to CFGs, but CFG give you kind of the support as well as the knowledge for you to get into those tech roles after switching your career. And then you have agency work, which is you go into the agency for 6 months. They train you in the language that you want, whether it's SQL, Python, and then they place you into a company for 2 years. And that again allows you to build your skills and build experiences to work on different projects. Emma asked, do I know any tech agencies? FDM is one. Is it Sparta Global or Spartan Global is another one. What's this other one? It's a green. I can just look at the green template. I don't remember. I just know it's green. Their website is green. But it's another really great tech agency. If you guys want to know the name, feel free to contact me on LinkedIn for that name of that tech agency. Can't remember it now, but they were really good as well. So those are some of the things that you can do to get into a tech role. Um, I'm not sure if I finished my last sentence, but feel free to contact me on LinkedIn if you want the name of that tech agency. Gosh. And then, or the next steps is you could do a course with CFG, or you can self-study as well. So if you can go to Coursera, you can go to Udemy, or you can look up SQL on Google and try and do some projects to learn how to kind of code in SQL. Also doing going to sites like HackerRank or Code Signal or Leak Code to practice coding. That would also be another way for you to self-study as well. Other skills are programming languages, data stream, platforms, Apache Kafka, data security, statistics are other things that you can learn while you're learning SQL. Okay, so to summarize what we've learned today is SQL is one of the most sought after skills that employers are looking for, and you can get any answers, and they can all be insightful from any questions that can be asked by your business. And it also helps that, like, if you're working with data, you do earn a sizable amount to keep you comfortable. And I always believe that learning data, you're not stuck in one kind of profession. You have various projects and various information that you can gather from data, and it's always very interesting. It's always very useful, and SQL is always great. As you can see from today, is great and easy to learn because it's structured similar and close to the English language. Okay, there's a few questions. Anne is asking questions about projects. How do we choose a first project? I would say think about something you're interested in. Think about something that, like, if you're interested in science, look for, let's say, a science data set. Can you put it into a database? So MySQL Workbench is a free database that can be used by any student or anyone. And in the SQL data course with CFG, you get to use MySQL database, and you can put that data into your database and start querying it. And that's how you can kind of play around with your project. Or let's say if you're into Spotify music, I've seen students that I've taught take data related to Spotify and actually query that data. So focus on something you're interested in, collect the data based off that, and then start querying. Start creating your select statements, start creating your projects, and yeah, you'll be well on your way. Bianca is asking, could you tell us a bit more about the data assessments for Nanodegree? So to get into the Nanodegree, you have to kind of meet a few requirements, but once you meet those few requirements, one of the requirements being you kind of attended one of a CFG course, whether it's Python, SQL, or web development, or done a similar course outside, then you would have an online interview, so kind of like a tech interview, and that would be based off something you've learned in one of the CFG courses, but also kind of the basic knowledge that you know from any outside courses that you have done. So I would suggest to prepare for a data assessment with CFG, um go on websites like HackerRank, Code Signal, Leak Code, I can't think of another one now, but websites that allow you to practice your skill in SQL, in Python, and that's kind of how you get comfortable with assessments, and that's how you get comfortable with coding assessments and code and tech interviews as well. And it's similar to what CFG would give you as. Also, I would say go on YouTube and look at the tech interviews or coding interviews that a few people have done for different companies, because they would all be on YouTube as well. Well, some people do them and put them on YouTube. So that can give you a good idea as to how to approach tech interviews in general. Does that answer your question, Bianca? So that is everything for tonight's MOOC. I just want to say that this MOOC will be available for, let's say, a week or two after tonight's session. So if you really want to, sorry, not really want to, but if you want to revisit tonight's content, if there was something that you missed and you want to just come and pause on what I've said, please just revisit the link. Revisit the site or the video through the link that you clicked on tonight. Also, you can see more of CFG's MOOCs on courses that they have running for the month of March on their website. So I'm gonna give you a link in the chat now. So there, with this link, you'll be able to visit CFG's website and view what MOOCs they have available, and then to see what courses they have available as well. Please visit that link. But without further ado, thank you guys for being with me and sticking through my coughs, my sneezes, and the interruptions, and also just thank you for also being interactive. I really enjoyed tonight's session and teaching you guys. Feel free to reach out to me on LinkedIn if you have any questions relating to any of the things that I've said today. But yeah, enjoy your evening, guys, and I will see you another time. Bye.